In a previous video, we talked about the main electronic concepts that I consider the most important to know when first getting started into electric or electronic engineering. Now, I want to discuss how some of them are related when they get involved in a circuit. To do this, I will be talking about the Ohm's Law, one of the most important theories in circuit design. My name is David from Darknatic, so let's commence. A French chemist and physicist called Henry Cavendish electrocuted himself to measure the intensity of the current depending on how much pain he felt. He first introduced the question what power or velocity the resistance is proportional to. With power or velocity, he meant the intensity of the current. In 1781, he first found that the resistance varies as the intensity of the current does. Even though this was found 50 years earlier than Ohm's discovery, which was absolutely separated from Cavendish's, that was never published or shared by Cavendish himself, and it was, for instance, published by James Maxwell in 1879. In 1827, Geroge Simon Ohm, a German teacher and mathematician, published Mathematical Consideration of the Galvanic Circuit. In that book, he described how current, voltage, and resistance are related in a circuit of homogeneous conductors, which is nowadays known as Ohm's Law. The Ohm's Law states that the intensity of the current in a circuit is directly proportional to the voltage across the two extremities of the circuit and inversely proportional to the resistance. Mathematically written, the Ohm's Law states that the current is equal to voltage over resistance. Thus, from this equation, we can find any of the variables known to one. For example, if we want to calculate the resistance in a given circuit, we need to know the voltage and the current. And if, for instance, we want to calculate the voltage across the two extremities of a given circuit, we need to know the current and the resistance. Alright, so now that we know those two equations, let's do an example. We have this circuit right here. We have a 3.3 volt power supply and a 47 ohms resistance. And we want to know what's the whole current in the circuit. So from Ohm's law, we already know that the current is equal to voltage over resistance. And if we replace that with our information, we have 3.3 volts over 47 ohms. So let me calculate that here real quick in my calculator. And we're going to have that current in this circuit is equal to 0.0702. But if we use, scientific notation, this is going to be equal to 70.2 milliamps. Okay, perfect. So let's go with the second one. In this case, we have a circuit of 100 ohm resistance and a 5 milliamps current. And we want to calculate the voltage. So from the Ohm's law, we know that the voltage is equal to current times resistance. So let me go ahead and replace that. Voltage is going to be equal 0.05 amps times 100 ohms resistance. And if we calculate that, we're going to have that the voltage is equal to 5 volts. Easy peasy. Alright, so in this circuit, I have a power supply of 3.3 volts and I have a current of 0.0015 amps. And I want to calculate the resistance. So we already know that resistance is equal to voltage over current. So let me replace that with my information. And I have 3.3 volts over 0.0015 amps. So let me go ahead and quickly calculate that. Okay, so I have a resistance of 2,200 ohms. Now that we have reviewed the Ohm's law theoretically, let's take a look at how it looks in real circuits. In this first circuit, I have a power supply connected to a 1000 ohm resistance and a red LED. So if I increase the voltage and I keep the resistance fixed, according to Ohm's law, the current will increase. So the LED lights up brighter. And inversely, when the voltage begins to drop, so does the current and the LED will dim its light. Now, I have connected a variable resistor of 10,000 ohms, and I have set up my power supply at 5 volts. So let me start reducing the resistance, and now we see how the current starts to increase as a result of it, and our LED lights up. George Ohm gave the term resistance a scientific value by demonstrating through his experiments that the resistance is a real physical quantity. This earned it the unit of measure of resistance to be named after him, Ohm. I really hope this video was informative, that you like it. Please subscribe to the channel. My name is David from Dogmatic, and I'll see y'all in the next one.